Welcome everybody to your channel, Thermal Engineering Concept and Principle. And in this episode, I will introduce the use of dry geothermal power plants technology. Of course, this is one of three types for the application of the geothermal source in producing electricity. So let us start our journey to find out how this system works. The main objectives of the present video are Rankine cycle operation principle and how this cycle works to extract energy and change it to electricity, and the geothermal power plant and how the temperature profile for the underground field and how it varies with depth. We have the types of geothermal power plants, and we will describe one of them, which is the dry steam geothermal power plant in the present video. And finally, we have the closure for our episode and the contents of this video. The point which should be known for engineers and for the public, of course, uh, is, is how can we extract this energy and convert it to electricity. And maybe the fundamental cycle for it is called Rankine cycle. And Rankine cycle is a thermal cycle. The simple one uh, composes four components: evaporator, turbine, condenser, and pumping unit is the pump. So in this cycle, energy is extracted from outside. It could be fossil fuel, renewable energy source, or even waste energy recovery sources, that where we can get these sources from the losses of industrial sites as well. And the energy is extracted in the evaporator, where the fluid, the working fluid of the cycle, evaporated and then passes through a turbine, where energy has been exchanged and changed to electricity with the aid of generator. And in that sense, the electricity is supplied to the outside, to the public, or where it is used. And the fluid passes through a condenser. In the condenser, a condensation process occurs. And usually we may use water for cooling, and that water comes from a river or lake, or even from cooling tower or geothermal reservoir. We can discharge energy to ground, or even for technical use before discharging to the river, or maybe for agriculture purposes. And the fluid condensed, changed to liquid, and then pumped by the pump, return back to the evaporator. Then this cycle is called Rankine cycle. And at the end, we have uh, extract energy from outside, and then we change it to electricity. So the fundamental is how to get the energy from outside, and then in this unit we will convert it to electricity. Now let us consider the geothermal energy and the temperature variation as we go deep in the ground. We may find this table in the open literature, which shows the variation of temperature with depth. For example, for depth between 10 meters up to 200 meters, then the temperature will be around 30 Celsius. If we go deep to 2.5 kilometer, then the temperature may range between 30 and 90 Celsius. And if we go more deeper in the ground, up to 5 kilometers, then the temperature will be more than 150 Celsius. Of course, this range of temperatures and depth gives a sort of guide to know about the temperature variation of Earth with depth. But again, it depends on the climate and the geological structure of Earth. There is a term called geothermal gradient, which refers to the average rate of temperature variation with depth. For example, in Europe, the geothermal gradient approaches 30 Celsius for each 1,000 meters. Of course, this is again a general guide. It depends on the earth where we are dealing with. For example, in Iraq, uh, some of the studies show that the temperature variation is around 21 Celsius per 1,000 meter, and maybe in other places you will find another value. So it depends on the climate and where we are treating these values for geological effect. So, in using the geothermal energy for electricity production, we may pass through the types of power plants. The first type is called the dry steam geothermal power plants, and usually they extract steam at temperature greater than 235 Celsius. And the second type is called flash steam geothermal power plant, where water is extracted at 182 Celsius, and as it rises up, the pressure drops, and a part of that hot water is evaporated and then passes through a cycle to complete the power production. And finally, we have binary cycle geothermal power, which uses an intermediate cycle, or we call it other fluid, in a heat exchanger, which extracts energy from hot water uh, that is extracted from Earth at temperature range between 107 to 182 Celsius. In this part, we will talk about the dry steam geothermal power plant. And one of the oldest fields of the geothermal power plants was uh, established in Italy in a place called Laderello, and the plant was uh, installed at that time in 1904, and still it's operates in that field. Although we have another place where we can find a dry steam is in California, and this source is rarely to be used because there is no uh, too many places where we can find dry steam coming from the underground. And now let us talk about uh, thermal energy and how geothermal energy is converted to electricity. For this cycle, we have a system called the dry steam geothermal power plant. In this system, steam is extracted from earth. We call this part as production well, where it provides steam, and then the steam passes through the turbine directly, and the turbine is a part of the Rankine cycle, which we have described earlier, produces electricity to supply for modern life use for factories, for domestic, for governmental state bureaus, and so on. And at the end, we will get the condensed fluid from this cycle, return back to a well called uh, injection well. So in general, for this type of power plant, geothermal energy is used, steam extracted from earth, and usually this is at a temperature higher to 235 or something like that, because we are talking about uh, Rankine cycle, which needs fluid or steam at a proper temperature to be converted to electricity. The dry steam, which is extracted from earth, cannot be used directly because it is usually carrying salts, some parts of the rocks. So we have to take off these solid parts. Otherwise, it will destruct the turbine blades. And the operation of the separator, uh, which can be used in this type, in a process that steam from a production well, usually at temperature higher than 235 Celsius, as it rises, it will carry over some particles with it. So we have to pass it through a rock catcher where large solid parts can be captured in this part. Then it passed through a separator where the fine solids can be separated from the steam stream, and some of the condensate will be accumulated at the bottom of the separator, which can be um, uh, withdrawn to be returned to uh, injection well, and the dry steam will pass through a turbine which um, turns these blades and a rotor to produce electricity with the help of a generator, and the steam then at low pressure will pass through a condenser, a heat exchanger, which condenses the steam by using cooling water coming from cooling tower or lake or any other source for cooling water, and the condensate will be pumped through a pump which can return the condensate to the injection well. So in that way we can clean the steam before passing through the turbine. And we can talk about overall conversion efficiency, which is equal to W divided by m dot times enthalpy of the source times 100. Here we have W, the running capacity, which is kilowatt electric. M dot, it is the mass flow rate of steam that passes or extracted from Earth. And we have H represents the enthalpy of the source. Then we may estimate the uh, efficiency of the power plant. And for this type, it could reach a value of 20%. And if we uh, think about the separator, then this separator should be cleaned periodically to prevent any mineral buildup in the system. And now we arrived at the final part of this video, which was about the use of geothermal energy in the dry steam geothermal power plants. And we passed through uh, the meaning of geothermal energy, Rankine cycle technology, and how it has the ability to change the energy to electricity and its main component. And finally, we describe the right geothermal plants. So, if you feel that this video is of advantage and useful to you and others, please subscribe and share it with others. And I hope I will see you next time in other videos to be released soon.